Good afternoon to everybody, and I would like to also thank GSA for this opportunity and Sandro. The only negative side actually is that I am after Wally's presentation, and usually it's not a very good thing because I have to keep up with his kind of presentation, so I will try to give my best. So I will go through this basic outline. I will start really low to be sure we are on the same page in terms of definition. I will go through a slide showing the pervasiveness of AI that has been said already before. It goes through different domains in each and every single vertical. I will go through a building block and the ecosystem that is extremely important because depending on those parameters, you will differentiate a huge amount of business model that you will see in the supply chain and in the industry today. I will go on the semiconductor side, talking about something that has been already touched, microcomponents, so MCU and SoC, and new accelerator, as well as memory component that are a lot of time neglected in this AI discussion, but are extremely important. I will say that are even the bottleneck nowadays. Finally, I will go on a brief discussion about the challenges and the opportunity for everybody here to make money out of artificial intelligence, machine learning, neural net, and deep learning. Actually, machine learning, neural net, and deep learning is more what we will talk about today. And last but not least, what is expected from an analyst, a bit of overview of two key domains. One is HMI that has been driven by AI, and another one that is very promising is an industry vertical that is automotive. So about the definition, AI, just to be sure, is a science that studies and enables a machine to perform a sort of intelligence. The intelligence could be in different way. It could be simple inference, learning, knowledge representation, or decision making. So to be an AI system, you don't need to have all of this, but you need to have even one. When we go to instead machine learning, the definition is in the word itself, is in the learning, the ability of the machine to learn by itself from the surrounding, from gathering data, important element, data from the input from the sensor around, and not necessarily because a developer or a software engineer is acting to update the system. As part of machine learning, we have a neural net and deep learning. That is, I would say, most of the progression in the latest 5 years have been going through this type of models. It's computational model that try to mimic, simulate a bit human brain, with its neuron as a cell of a computational cell and synapses that connect the various cells together. AI is quite pervasive. It has been already touched before, but I would like to touch again and look at the various domains that are really actively working or already implementing some AI machine learning algorithms. And we are talking about autonomous machine, monitoring, diagnosis, predictive maintenance, is a huge amount of possibility in efficiency and cost reduction, quality and testing, even up to cybersecurity. And each of single domain altogether can be applicable to all the industry vertical you can think of. Transportation, agriculture, oil and gas, energy, and automation and manufacturing. And the implementation goes from the cloud, that is thousands of nodes only, but very intense in terms of processing, down to the edge point devices. You can have robotic arm, your auto is an edge device, you can have your smartphone or even your smartwatch. And passing through this layer that, as Wally said before, is edge network or fog, in other words, that is a lot of opportunity there with the new devices like industrial PC, gateway, data center, and PLC also, that are getting more and more intelligence inside. And this intelligence usually is driven by some type of AI mechanism. All this spectrum that is pretty variegated is driven by, I will say, major 5 critical requirements. And you can permute this and have a differentiated market and application. And these are privacy and security, because again, we said the AI is about data. And you might have some concern about the privacy and security of this data and transmit these from the application to the cloud and vice versa. But also latency is one of the critical ones. So if you have a real-time application or safety critical automotive, this is very important, so the latency goes in the direction of the edge point. While consumption and processing power are very much together, so you might have a huge power requirement in the data center, but less in the clearly handheld and all the bunch of IoT devices that will proliferating in our life today. Final is cost of also in terms of data communication, and this other key element that is moving to the edge, the computational capability. So a small discussion also about training and inference. When we are talking about neural network and deep learning, it's important to keep in mind that we have two key phases. One is the training and one the inference. And these two phases needs to be taken well into account because the infrastructure is different, the software is different. So the training is for probably you know everybody knows about this. Let me two seconds to clarify. So the training is when in the development phase you give a lot of data, you feed your model till you get the accuracy you want, and then you implement to the real-time application. In your final product, you get a new input data and you get the output, expected output. So as you can see here, you might have completely different scenario. You might have to run as always happen, the training in a data center because you have a lot of processing power. And the power in terms of energy consumption is not a big issue. Vice versa, at the opposite end of the endpoint, many of these IoT devices are very critical in power consumption. But on the other side, positively speaking, you will have less processing power requirement, apart from probably automotive, that is the nasty environment. So all these scenarios increase extremely the opportunity for AI. And for me, this complex ecosystem, which I discussed in the previous slide, is pointed out in three major factors that are disrupting all the industry. One is software, because you need specific algorithms, and no one knows about that. So the experience and the competence in our industry is not that high. The hardware, because as Wally said, and Infineon before us, hardware is something that is not exactly optimized to solve neural network, deep learning type of operation. So a lot of the startups are coming exactly to address this topic. And last but not least, as been said already, is data. There is this function of the chief data officer in many companies now. So the key message is the importance of data analytics sorry, in the very industry, whatever it is a semiconductor up to the vehicle manufacturing. And this is exactly the feedback that we got when we are doing our survey. So basically here is the organization alignment is one of the lowest score when we are looking at the readiness. So within the company, you have to be sure to align the expectation. You have clear the business model to address what makes sense for your company, whether in lowering cost or increasing your revenue. And also in terms of impact, this is more or less the key points. I'm not sure I would agree fully with this. The employee will be less impacted. Probably in the short term, yes. But this is another discussion, as Infineon said before. We need to be sure that the impact in employment will not affect that much our society. So let's go down to the semiconductor now. So 5 years ago, I think it started a sort of migration toward a sort of multi-purpose heterogeneous computing platform. And I think from, I put here the top three, allow me to say, not take it personal for the other, that are actively in the artificial intelligence machine learning. So we have the NVIDIA GPU, started with the GPU, the Intel CPU, and Xilinx FPGA. And I include also ARM because they were focusing very much on RISC type of IP. If you see what is happening, and the latest announcement of all the companies, they are adding more and more dedicated core units and computational unit in their application. And they are slightly moving out from GPU, CPU, and GPA and FPGA. So even Xilinx, I don't think they will be happy to be called an FPGA company now after the latest announcement or the ACAP type of platform. So they are moving, adding coprocessor, accelerator, whether it's deep learning accelerator, tensor accelerator. So an AI is a big driver, I think, of this heterogeneous computing. This is the reason why we are trying to break down the silicon contribution into AI in 4 major buckets. One is heterogeneous computing between advanced and I will say general purpose. And the other 2 are extremely important, has been discussed already today something. I would like to point out first MCU, because there is a huge opportunity also for, allow me to say, trivial MCU to add extra value with microcontroller, simple microcontroller. And you see already the big guys like the Infineon, ST, NXP, and Renesas are all working on this area. And I think there is a huge opportunity when we are talking at the bottom of the pyramid that I showed before in terms of IoT devices. Whether it's software-based only, using standard off-the-shelf type of MCU, or we are talking about adding an accelerator, doing a couple of multiply and accumulate to add the value at the standard architecture. Last but not least is discrete coprocessor and accelerator. This is another category where basically we have all the startup that even Wally was talking about before. And here again, don't take it personally if your name is not here. It should be a pixelated image, the 1 pixel for each company, because really has tens, if not hundreds, of new startup coming in. And they clearly bring, the business model is clear, that brings some advantages of the traditional solution that are, in terms of semiconductor, available on the market. Optimized performance and consumption, so energy efficiency, is something that is totally missing, I think, in today's semiconductor. Customizable. And the important thing for me, the most important, is that many of those guys are targeting not just the architecture from the computational perspective, from the processor unit perspective, but they are taking into account the memory. So they are trying to use the human brain experience, and we don't have our memory that is on our feet, right? The memory is exactly where the brain is, together with the computation. And some of these companies are taking this as approach, like Vadis from, they showed a very nice way to reduce the power consumption as well, increase the efficiency. There are some challenges though, because first of all, the number of startup, and there is a couple of points here that needs to be taken into account. First of all, AI is quite dynamic. We are not in a steady state. I would say, although you might think it's a disillusionment point of the Gartner curve, but I believe that actually AI is really at the infancy. So if you are developing something that is too strict to some type of algorithm, you might have problem later on when the AI develops in terms of networks, in terms of algorithm. Another big challenge that I see is software and hardware. So it's already 2 years that I'm giving a message that silicon is not the only point the semiconductor companies to focus on. More and more software is coming as added value. And this is the major movement of the key players that you see very active in the AI, NVIDIA, Intel, Xilinx. So the addition of the software and create a solution and a complete platform is essential for the added value. So those companies might have some challenges. I said briefly about the memory before, and I want to come back to this point, because if we are looking at application like automotive, we are talking about 10 teraflop operation embedded. So if you are looking at the off-chip memory that today are used, they are consuming about 50 picojoule per byte. So if you make a calculation, you end up to have a kilowatt in your car. And this is the reason why at the end, so all the boards and the system that are targeting level 4 and level 5, you are having a sort of, let's say, water cooling, right? And this is not to be surprised. But the problem is not the power consumption of the SoC. The problem is the power consumption of the memory that is an order of magnitude higher. There are other opportunities, so even if you have a monolithic array on chip embedded, you still have a problem. You go down by a factor of 5 or 10 even, but it's still a problem. So you need to go down to really new architecture. That is what these startups are trying to architect, to have a central computing unit very close to the memory as well, the active memory, not the storage. And there are also some interesting solutions with resistive memory and phase change. I think are more on the longer run with some analog type of AI. These are very interesting, at least from the R&D topic, but I think probably are still a bit far from the production. So let's go to the market, what probably is more expected from me. I want to show two examples. One is HMI, and I will say it's an horizontal domain. So HMI is where already today you see the development, what is the added value that has been developed in the last 5, 10 years with the artificial intelligence, and why. So in the past, basically, there were not technology that were available at a reasonable cost. So display were not available, and AI as well. This is completely changed today. And a lot of the customer needs and the user experience as well has changed. So the influence of consumer electronics has been significant. And this is what you see together with AI that happen in the human-machine interface type of application. And this is the reason why HMI, I think, is the first domain showing a huge development and showing also a huge revenue behind it. Because it gives a lot of added value, AI, also in terms of brand differentiation. So it's not added value for the end consumer, also for the brand. It's also with your voice, spatial voice, the BMW, for example, let's look at automotive, or even the smartphone. And so it's added value everywhere. And then limited performance and cost. So the performance in terms of computational power or memory is not extreme. And then you have a steady algorithm, you have a huge amount of data because of consumer electronics, because everybody has 1, 2 smartphone, laptop, tablet, and so on. So the amount of data behind you can build your speech recognition or your virtual assistant are there. And last but not least, it's not safety critical. That means deep learning, as everybody knows, artificial intelligence is a sort of black box. So you know what's coming in, and if something gets wrong on the output, you don't know exactly how to cope with that. And this is a huge problem for artificial intelligence applied to safety critical application. But the biggest one is ubiquitous. So you make a development for smartphone, for example. It was born in smartphone in a speech recognition, right? And you move it to smart speaker in consumer, in laptop. And now you see that moving strongly in automotive. Alexa will come in the next generation of vehicle. And also in industrial automation, for example, we see clear indication. And this is just to confirm. We are talking about $8 billion in 2018, coming by almost a factor of, I would say, 3 in the next 3 years. And an interesting aspect, in my opinion at least, is that if you look at the competitive landscape, it will be completely disrupted. So there is a lot of modification coming there, a lot of players coming in with new features. And I think the major reason of this disruption is also a sort of, not for geopolitical reason mainly, probably also that one, but there is a sort of a different approach due to cultural and difference in language between East players and West players. Also the success that the Siri has not been so strong in China, and vice versa, other players are not from the East country are not that successful in the West country. So this is last slide. I skipped this because probably I'm a bit late. And I will go to the automotive. Automotive is the domain. You solve the automotive, you are a billionaire, and you can apply all your knowledge everywhere. So because automotive has all the possible constraints you can think of in nowadays. One is cost, performance, power, and safety. And if you look here, these are the major considerations. So to level 4 and level 5, I don't think we can get there by 2030. So Luckily, the automotive day is tomorrow, so probably there is no one here that can be against me. But I'm really pessimist on the fact that level 4 and level 5, you will get it before 2030. And one of the critical issues is not the power or even the cost. Probably you can get down to reasonable power and performance by that time. What I'm concerned more is the business model and the safety. So you need to have a lot of effort on R&D to dedicate to fix the requirement for example, deep learning and machine learning in the auto, because auto needs this type of algorithms, but needs to be safe. And so far, this predictability of AI behind the wheel is not 100% sure. Even there are some struggling in the ISO 26262 committee. The business model you can find, but probably by 2025, you will have a level 4 car, but it's not a car that you drive or I drive. It will be a robocar. So there is a business model behind the robocar. So the robocar has a business model to get the return of investment of 10,000 electronic equipment that no one of us will probably be able to afford in a private owned car. Assuming a private owned car is still a business model for us in the future. I conclude with this. It's a small analysis that we did in terms of infotainment and ADAS. The amount of shipment that are in the vehicle today based on AI. As you can see, are not that many. And I tell you, the big portion, especially driven by this 50 million here, is infotainment, where there is no safety critical functionality. The rest, there is some ADAS function, but it's not active. Again, it's not steering the wheel or braking the system. It's some assistant driving function. With this, I conclude. Thank you for the attention, and I give it back to Sandro. Thank you.